All right, here we go. 19.1, 19.2. So this starts with central case study talking about the Keystone Pipeline. Okay, this is like the epitome of ping pong in politics, basically. Like it gets approved, it doesn't get approved, it gets approved, it doesn't get approved, back and forth, back and forth. The basic idea is this here. They're proposing that dashed line right there. Because basically the oil sands from Canada, which we'll talk about in a bit, they're basically wanting to pipe that stuff down to where it can get refined. The original pipeline, as you can see, all of this is basically talking about a big massive aquifer. That's what they're trying to avoid. Because if that pipeline bursts even just a little bit, little spills, that could just absolutely decimate that entire aquifer. So the black solid line, or excuse me, the brown solid line, that's the existing one. The extension is what they're talking about here. Like Obama, for example, said that wasn't going to happen. The Supreme Court sided with him. Then Trump got in the office and signed an executive order saying it could work, and now it's in the courts and back and forth and back and forth and back and forth. So it's basically just kind of like the economics and the profit going head to head against environmental concerns and environmental agencies. So sources of energy. So we're on page 517 here. So as a society, we are becoming increasingly dependent on fossil fuels. Coal and oil and natural gas are the three big ones. But renewable sources are catching on, luckily. Now, this book is citing a bunch of graphs from like 2015, 2016. So you can see some of the energy sources that we use, but some of the renewable ones you can see on the bottom here, these are starting to become more and more and more and more and more popular. Like I saw, I think it was last year, like the end of last year, was talking about how solar has taken over as the main source of energy for Texas, which is a really big thing. As you can see, like the global consumption of this stuff is going up. However, those renewable resources are starting to make them start to decline. Like you can see, it says 2015, so it's a little bit dated. All right, moving on, page 518. So there is definitely an uneven distribution of fossil fuels and their use throughout the world. Not only where they are located and where to mine them, but also how much they are used. So this image here on the bottom is just the epitome of basically kind of like America leading the world in stuff we shouldn't be using, or we shouldn't be leading the world in. All right, so sorry, I'm going the wrong direction. So you can see it says the average U.S. citizen uses 7.2 tons per year. Okay, and if you didn't know a ton is 2,000 pounds. So we're using like over 14,000 pounds of oil per person per year. That's what's happening in America. Look at the bottom though. It says the average person uses 1.79. So we're somewhere in the neighborhood of 6 to 7 times the rest of the world on this stuff, because basically we just like to consume things. So this picture over in this diagram or this chart, whatever it is on this side, on 519, I simply write know these. What this is basically talking about is that, like it says in the blue up there, it takes energy to make energy. So you can't just simply get it for free. Like there needs to be input put into the system in order for energy to be pulled out of the system. For example, even like the solar panels and wind farms, stuff like that, there is energy putting in to make those products so that way they can produce energy. Okay, so the gray side on the right, or the kind of the beige thing with the losses. What the losses are is talking about basically waste heat. For example, oil going into transportation. Think about your car engine, it gets hot. So a lot of the energy from oil isn't used to make your car go forward and your air conditioning turn on and your radio work. It's simply lost as heat. And I've heard stats that basically it's only like 16% of the energy in fossil fuels is actually used for your car to make the car move. So it's not a very good, not very good turnover of energy is what it is. You can see natural gas, and you can see the different sectors of the world it's going to. So you can see like natural gas goes to industrial, goes to commercial, goes to residential, but a lot of natural gas is going to electricity generation, which then feeds back into these systems. So like a lot of coal goes to the coal-fired power plants, nuclear power plants, renewable power plants, all that kind of thing, going into electricity generation. They also use a thing called the terminology called net energy. So that's basically the net energy is the energy returned minus the energy invested. So like how much energy it took to make that solar panel versus how much energy it returned from that solar panel. That gives you your net energy. Next page, going to 520. There's a thing called the EROI, or the energy returned on investment. All right, so a high EROI means that for a little bit of investment, there's a big return. For example, let's say it cost me, $1,000 to build a solar panel, and I stick it on my house, and then basically I generate enough energy that I could sell it back to the power company, and then I make, $20,000 that year from it. That's a really high EROI. I spent $1,000 and I got back $20,000. That's really good. Now, the EROI for oil, like it says there in the bottom, is starting to go down because fossil fuels are getting harder and harder and harder to find because we're starting to deplete them around the world, which is obviously not a very good thing. Now, fossil fuels, they come from, and I like this diagram here, they come from organic material. So time, you can see the time on the top there, time is moving from left to right. So you get your ancient forest on the left-hand side, so this is a long time ago. And as time moves on, you can basically see how it's basically getting in sediments, and it's increasing heat and pressure. It's basically pushing and pushing and pushing and pushing and pushing down until you have a whole bunch of different types of oil. Okay, this is not necessarily, like it says ancient forest, or you think of obviously like the trees. This also can come from animals. He's always talked about, fossil fuels are, we're running on dinosaurs. Okay, marine sediments like phytoplankton and zooplankton are actually a big kicker behind this whole thing. Now, how we find deposits of oil is actually kind of interesting. Basically, if you guys know what echolocation are, like sonar and radar, it's the same basic idea. You basically put out a vibration here instead of sound. They put a vibration out, and based on how the vibration hits and where it comes back and the time it takes for it to get to those receivers, that's what all these guys are using to find oil. They basically vibrate it, and then they basically listen to see when it comes back, how quickly it comes back, the shape of the curve and everything. It's kind of an interesting process. So there's a bunch of things here on the bottom. I didn't put a sticky note on the next couple of tabs because basically they talked about kind of the whole different kind of the traditional fossil fuels, but they also talk about unconventional fossil fuels. So like oil shale, you can see down here at the bottom, oil shale, shale oil, and methane hydrate. Okay, these are the things that basically aren't being used very much as of yet, and still as of this year, 2021 and 2020. Okay, here's basically the two processes on how they get this stuff out of the ground. So there's the strip mining, which we've talked about before. They're basically just digging a big gigantic hole. Then there's the steam and solvents, or the steam extraction methodology. Obviously, that is much less impactful on the environment than basically building a big giant hole. Obviously not the greatest for the environment, because now you're taking out the things on the bottom, which everything is resting on. And we've talked about that. Like if we're pulling a whole bunch of stuff out of here, like potentially that's the reason more earthquakes are happening in Nebraska. So moving on to page 525, this is basically what an oil refinery is. I'm not sure if you've ever seen an oil refinery. They got a whole bunch of towers like this going on. And the reason for it is there's a whole bunch of different products that come out of basically crude oil, depending on how hot everything is. So you can see like fuel oil, lubricating oil, diesel, kerosene, gasoline, and so on. Okay, it's depending on how hot or how cold, well, the different degrees of heat is more than it is. That's what's happening. So the thing I wrote in the sticky note here, so we talk about a proven recoverable resource. So the extraction costs equal the market price. So basically you can make money. Like if the extraction was costing more than what I could sell it for, nobody would do it. So if profit increases from the product, more of that product is pulled out of the ground, is extracted. And the economics that drives extraction. So if the demand for oil is increasing and the profits from oil is increasing, more oil will be extracted. And that's basically what we're doing these days. The demand is going up, the price is going up, so therefore the demand to drill more and extract more is also going up. Next page, okay? This tip simply talks about fossil fuels have many uses. I'm confident you guys know that. Okay, here's an example of this picture here of a coal-fired power plant, which I think is kind of an interesting way or kind of a nice way to look at how the whole thing works. Okay, so number one, coal is pulverized or basically broken up. Okay, like basically think of a big jackhammer, or like think of that as like a big blender. Okay, breaks the whole thing up, then it's tossed into the furnace. The heat from the combustion boils the water. Okay, the steam from that turns a turbine, which rotates magnets, passes copper, blah, blah, blah. It's basically, this idea is the same thing as like a hydroelectric dam, but just with coal. That's what's generating the turbine to spin. All right, moving to 527. All right, so now we got the reserves to production ratio. So how much we still have in proven oil reserves compared to how much we are using. And that's the big difference here is the proven oil reserves. They're always searching for more of them, but the calculation is based on what we know as of today or as of 2016. Okay, and it honestly hasn't changed very much in the last 4 or 5 years. Okay, so proven oil reserves, we got 53 years left. Okay, for natural gas, we got 54 years. For coal, we got 110 years. But keep in mind, the demand is rising year after year after year. So the calculation that happened 5 years ago isn't going to be the same for right now because the demand is rising every year. So the amount that we still have is the same, but the demand is rising. So the number of reserves or the number of years that we have left is going down. Okay, this picture here, I'm going to move that real quick. Okay, shows basically all the different things that we use petroleum for. Okay, which might honestly kind of surprise you. Obviously we know like gasoline going into a car. We know that, asphalt going into the ground. We know that part. But like, vinyl and plastic laminate furniture. That's one of them. Plastic cups and dishware, containers, components, dishwashers. You got shoes with synthetic soles. You got your shower curtain, your shower head, the plastic fixture. Like all of this is based on petroleum. All of it is. So if you talk about, some of the environmentalists talk about we got to get rid of it today. That means we got to get rid of all of those products today as well. So 528, we're starting to see a drop in the amount of fossil fuels being produced. Like I was saying, we're starting to run out of like basically where to find them. Okay, technological advances are helping, but a change has to happen soon. Like I was saying, we're getting the production and the energy amount that goes into like a solar panel, for example, that energy is starting to go down, thankfully. So they're being produced at a lower cost. All right, Dave, answer some questions or create some questions. We got something to talk about.